Hello everyone. So in this lecture we will be discussing about the minimum deletions to make to a string such that the string becomes a palindrome. So we need to devise an algorithm such that if we are given a string, then we need to return the minimum number of deletions that are to be made to the string such that the string becomes a palindrome. Now suppose we created a function and that function gets passed with a string abcde. So how many characters do we need to delete from this string such that the string becomes a palindrome? So we need to delete at least 4 characters in the string such that the string becomes a palindrome. Now in the second example, if we take now what are we given? We are given a string acda. So how many characters do we need to delete in the string such that this string becomes a palindrome? We need to delete a single character, and that single character might be C or D. If we delete D, then we get a string ADA, which is a palindrome, and if we delete D, we get a string ACA, which is again a palindrome. Now we would be looking into our base cases, and before that I highly recommend you to just go through this thought process, have a look. So what does this say? This just checks, or this just asks you that the minimum number of insertions which we have already done. So if we are given a string, so the number of insertions we need to do into that string such that the string becomes a palindrome, will that always be equal to the minimum number of deletions which we make to that particular string such that the string becomes palindrome? You just think of it. If the answer is yes, then why it is yes. If the answer is no, then why it is no. I will be discussing it at the end of this lecture. So I highly recommend you to pause the video, give it practice it once, try it, and then come back to the explanation. So I would be starting with the explanation now. Now what do we have over here? We have a string AEBCBDA. Now what would be our base cases? Our base cases would be if we are left with only 2 characters. Now suppose you are left with only 2 characters, then how do I make this a palindrome? If I'm given that I need to make minimum number of deletions into this string. So in the case of 2 characters, I need to check whether my both the characters are same or not. If they are same, so I need not make even a single deletion to make it a palindrome, because that string in itself is a palindrome. So suppose if in this case I have got 2 A's. Now do I need to delete anything to make this string a palindrome? No, there is no need to delete anything. Hence we would be returning 0 in this case when both the characters are same. Now if we take AE, both the characters are not same in this case. So what shall I do? I should return 1 in this case. Either I should delete an A or I should delete an E to make this string a palindrome. So what does this 1 signify? This 1 signifies that if I am left with 2 characters and I need to make some number of deletions to make that string a palindrome, so I need to delete 1 character out of it. So this 1 tells that the minimum number of deletions to make a string of 2 characters into a palindrome is 1. Now the third base case would be if I am left with only 1 character. The first base case was 2 characters, both are same. Second base case was 2 characters, both are different. The third base case is we are left with only a single character. So what do you think? Is a single character a palindrome? Yes, it is always a palindrome. So I need not make any number of deletions to it to make it a palindrome. Hence we will return 0 from this case. Now we do have other cases where the characters we are comparing are equal and the where characters we are comparing are not equal. So we do have some different recurrence relations for that. So we would first take a look at our recursive tree. We will understand all these base cases and non-base cases, and then try to make a recurrence relation out of it. Now coming on to our recursive tree, what do we have over here? We have a string AEBCBDA. This min-del is the function which we would be making use of to tell that the minimum number of deletions to make to a string. This string is either a pointer or a reference to the string which we will be passing in. This 0 to 6 actually gives us the range in which we will be trying our operations on. So this 0 says the minimum index is 0, the maximum index is 6, or we can say the lower index is 0 or high and higher index is 6. Now what do we check? We check is the last and is the last and the first characters are same or not, or the characters present at these indices are same or not. So in this case, are they same? Yes, both the A's are same. So what do we do now? What do we say is that, look, this A and this A are already in palindrome. So what do we need to do is, whatever be the answer to the leftover string, that would be my answer. Now what do? Is I just send EBCBD and I just increment low by 1 and decrement high by 1, such that now I would be making operations of making deletion operations in this range 1 to 5 or in this string EBCBD. So again I check, is my character present at low index and character present at high index, are they same? No, they are not in this case. So what do we need to do? We need to branch out. And how do we branch out? We just check, okay, just tell me, what if I send EBCB and ask you that how many minimum number of deletions you need to make to this string such that this string becomes a palindrome? And what other branch I say? In other branch I ask that, okay, just tell me BCBD, how many minimum deletions I need to make to this BCBD such that this BCBD becomes a palindrome, and then I add again 1 to it. Okay, why are we adding 1 over here? Look, now if we have got this string, we have got EBCBD, yes. Now we are asking that how many minimum number of deletions do we need to make in this string such that this string becomes a palindrome. So what do? Is we will check, is this is the last character and first character same? No, they are not in this case. So what do we need to do? We need to branch out in this case. We will check what are the minimum number of deletions to make if I delete D. So what am I left with? I am left with EBCB. And what are the minimum number of deletions to make if I delete E instead of B? So what I am left with? I am left with BCBD. So we would be recurring for these two branches and then check what gives me the minimum answer. Okay, so in the same way, what we did over here, I said that if I delete D, then what would be the minimum number of deletions to make such that my leftover string becomes a palindrome? And if I delete E instead of D, then what are the minimum minimum deletions to make such that this string becomes a palindrome? And I add 1 to it. This one signifies that I have already deleted a D in this case EBCB. That's why I would have got EBCB now. If I would have deleted D, then only I can get EBCB. And instead of D, if I delete E, then what would I be getting? I would be getting BCBD. So in either cases, either if I delete D or E, I need to add 1 to it because I have already performed a deletion before sending these recursive calls. So what do we check? Okay, just tell me how many deletions do I need to make to convert this EBCB to a palindrome. So again I check, is this E and B same? No, they are not. So I will branch out again. So what if I delete B and check, okay, what are the minimum number of deletions to make in EBC to make it a palindrome? And just tell me, if I delete E instead of B, then what are the number of deletions to make? And again I added 1 because in either of the cases I have deleted a character. In this case I have deleted B, and in this case I have deleted E. Hence I am adding 1. Now in EBC, is E and C same? No, they are not. So I will again branch out. I will say, okay, if I delete C, then what are the minimum number of deletions to make to the remaining string? And if I delete E instead of this C, so just tell me what are the minimum number of deletions to make in the leftover string? And I need to add 1 to it. Again, because in both the cases I have deleted at least a character. In this case BC, I have deleted E over here, and in this case EB, I have deleted C over here. Hence, due to that deletion, I have added a 1 over here. So whatever might be the answer to these recursive calls, I would have at least deleted 1 character, either E or C. Hence, I have added 1 to it. So what about this case? Here we have hit a base case. And what is this base case? The base case is that I am left with only 2 characters. So if I am left with only 2 characters, then what do I check? I check whether they both are same or not. Are E and B same? No, they are not. So how many characters do I need to delete such that this string becomes a palindrome? Again, I discussed how many characters do I need to delete in these two characters to make a string a palindrome. I can either delete a B or I can either delete a E. So in both the cases, I would be deleting one character. Hence, I would be returning 1 to this base case. Now, how many characters do I need to delete in BC such that BC becomes a palindrome? Again 1, because this is also a base case. So minimum of this one and this one is 1, and 1 plus 1 is 2. So this 2 signifies that how many characters do I need to delete in EBC to make it a palindrome? So the answer is 2. Look, if we check how many characters do I need to delete in EBC to make it a palindrome, so either I need to delete BC or I delete EB or I delete E and C. I need to delete at least 2 characters such that this string becomes a palindrome, and hence the answer is 2 over here. Now, what about this case? How many characters do I need to delete in BCB such that this string becomes a palindrome? So we will check, is my character present at index 2 and index 4 same? Yes, they are same. So what I would be doing? I would be just passing in the only leftover string, because B and B are already in palindrome. So what am I left with? I am left with a single character. And what I hit here? I hit a base case. Now what does this base case say? That how many characters do I need to delete to make a single character into a palindrome? So the answer is 0, because a single character is all in itself is a palindrome. So this will return 0. So the answer to this subproblem, that how many characters do I need to delete to convert BCB into a palindrome, it is 0. So min of 2 and 0 would be 0, and I would be adding 1 to it. So the answer to this subproblem EBCB is 1. And why is it 1? Because to convert EBCB into a palindrome, I just need to delete 1 character. This one, the solution to this problem 1, signifies that I need to delete only 1 character in EBCB to make it a palindrome, and that we can see directly over here. What I need to do, if I need to convert EBCB into a palindrome, I just need to delete E. My string becomes a palindrome, and hence we get the answer. Now the other could have been if I would have deleted E instead of D over here. Look, in EBCB, what did I delete in this string EBCBD? I deleted D. So I got an answer of 1 over here. So what if instead of deleting D, I deleted D? So what would I have been left with? I would have left with BCBD. So how many characters do I need to delete in BCBD such that it becomes a palindrome? Again, we would have recursed. In this case, I would have deleted D. In this case, I would have deleted B. In either of the cases, at least I would have deleted a single character. Hence, I would have added 1 over here. So this BCB is again a overlapping subproblem. You can see this min del BCB24, min del BCB24. They both are overlapping subproblems. Hence, the answer to this BCB would have been 0. I can easily say that because I can already see it over here. But we need to calculate in case of CBD. So whatever it might be, but if we check directly, then the minimum number of deletions we need to delete in BCBD would have been also 1. Look, because if I just delete D over here, so I get a palindrome. So minimum number of deletions in BCBD to convert it into a palindrome is only 1 character. Hence, this would have also led to us as a 1. So this is 1, this is 1. Min of 1 and 1 is 1 again, and I would be adding 1 to it. 1 plus 1, 2. Now the answer to this subproblem EBCBD would have been 2. And what does this 2 signify? This 2 signifies that if I need to convert EBCBD into a palindrome, so I need at least 2 deletions in this string. Then this 2 would have returned to this string, and which is our topmost problem and our intended problem. So the answer to this problem would have been 2. So I need 2 deletions to convert this string into a palindrome. So what do we see over here? Can we see our overlapping subproblems? Yes, that's the first property which needs to be fulfilled for the DP solution. Okay, we got one in our hand. What about the second property of optimal substructure? What do we see over here? Can this big problem be solved with the help of other minimum subproblems, or by minimum I mean to say smaller subproblems? Yes, it can be solved. we, with the help of all these base cases and all these sub problems, we just found out the answer for this intended problem. So it also has an optimal substructure. So we can directly see over here that it's a pure DP problem. So in the next lecture, we will be discussing that how to solve this problem with the help of DP. So coming on to the thought process, what we just discussed initially. So are the minimum number of insertions and minimum number of deletions to be done in a string to make a palindrome, are they always same? Yes, they are always same. And why do I say it? Look, because this, we will take this string abcd. What did we get our answer over here? For this abcd, if you remember, or you can rewind the video, we got 2 as answer. 2 says that we need to delete at least 2 characters to make that string a palindrome, and that 2 characters will be this D and this E. Okay, now what if I ask how many insertions do I need to make in this string to make it a palindrome? That would be again 2. Look, what are the characters which are hampering this string to make a palindrome? There are 2 characters. So for those 2 characters only, I need to make some extra insertions. Okay, I will explain with the help of this thing. What is the string abcd? If I need to insert the characters to make it a palindrome, what do I need to do? I need to insert a E to fulfill this E, okay, and I need to add a D over here to fulfill this D. So this string becomes a palindrome then. EDBCBDE. This string becomes a palindrome. And why? How did it become a palindrome? By adding 2 characters. And those 2 characters were added only to fulfill this single E and this single D. So if I delete those single D and E, so do I need to have any insertions? Or why did I have those insertions? I had those insertions only because those E and D were extra. So the minimum number of insertions that I have to make were only due to the characters which needs to be deleted from the string to make that string a palindrome. I think you might have got the concept. It might be a little intimidating right now. You can again rewind the video and check it what I am saying, and you can check that whether this statement is true or not. But what I told you, just listen to it carefully. So in this case, what all did we see? We have overlapping subproblems. We had our optimum substructure. So in the next lecture, we would be solving this problem. We would be having our code development and code go through for our DP solution. In that, you would be again having a good idea on how to solve these kind of problems and how did this exponential time algorithm gets converted to a polynomial time algorithm. So till then, thank you. We would be discussing all the DP solution in the next video. Thank you.